All right, welcome back. If you're on the shop floor, if you're running a press, or you're the one setting up the tooling, then listen up. This one's for you. Today, we're not just skimming the surface of die protection. Oh no, we are going deep, and I mean deep, into mastering the Wintress SmartPAC. So let's get to it. Time to take back control of your uptime.
Let's just kick things off with a fact that every single person in this business feels in their bones. A die crash, it's the #1 killer of your production schedule. It's that one catastrophic event that can absolutely wreck your entire week. And it's exactly what we're here to conquer.
But here's the twist. If you're looking at your die protection system and just seeing a glorified emergency stop button, you are missing like 90% of the picture. We're going to move way past that thinking today. This is all about a mental shift. It's about taking that SmartPAC, that little box on the side of your press, and turning it into the command and control center for your entire operation. This is about you, on the floor, achieving total process domination. So, mission #1 is to completely reframe this conversation. We are officially moving beyond just preventing a crash. That's playing defense. We're getting into the world of total process control. This isn't just a shield. It's your #1 weapon for peak efficiency. You know, when you look at a crash, everybody sees the obvious thing. The big repair bill for the tooling. That's the direct cost. But the real killer? The thing that just bleeds a company dry? It's all the indirect stuff. It's the lost production, the chaos it throws your schedule into. And it's that subtle drop in quality. Because let's be honest, a repair die never quite runs the same, does it? So, how do we win this war on downtime? Well, you need the right tools. You have a whole arsenal of in-die sensors available, and a real pro, a master of the craft, knows exactly which weapon to choose for the job at hand. And at the most basic level, you're always facing this choice, this fundamental trade-off. On one side, you have your inductive proximity sensors. These things are tough as nails. You can beat them up, cover them in oil, they don't care. But their reach is really short. On the other side, you've got photoelectric sensors. They can see a part from a mile away, but you get a little bit of grime on the lens and they can go blind. Your whole strategy starts with this choice. And this chart right here, this is your playbook. This is the cheat sheet. You don't just pick a sensor, you match it to the mission. You trying to confirm your stripper is down in a nasty, oily environment, inductive procs all day long. Trying to see if a tiny part got ejected all the way down a long chute? Through beam is your guy. When you master this chart, you've mastered the foundation of a bulletproof die protection setup. Okay. So you've picked your hardware. You've got your sensors in the die. Now it's time to give them their marching orders. This is where we get into programming. This is where you lay down the rules of engagement for your entire system. But before we even think about programming a window, we have to talk about something that is 100% non-negotiable. It's called fail-safe design. Look, a system isn't really safe if it's not smart enough to know when it's broken. Think about it. If a sensor wire gets cut, the system has to know about it and stop the press. It's that simple, period. And this is exactly how we put that principle into action. You got a yellow or a normally open sensor, and that wire breaks, the control just sees an open circuit, which to it looks like everything's fine. It keeps running. That is a massive blind spot, and it is dangerous. But a red, a normally closed sensor, needs that complete circuit to give the all clear. The second that wire breaks, the circuit opens, and the SmartPAC instantly knows something is wrong and stops the press. For any critical sensor, especially anything on the upper die, red is the only professional choice. All right, I need you to lean in for this next part, because this right here, this is the single most important concept we're going to talk about. This is what separates the rookies from the true veterans. If you can master this one idea, you will prevent crashes. It's called the critical angle. Now, what's so important to get is that the critical angle isn't some number you just guess at. It's not a software setting you can fudge. It is a physical reality of your specific press. It's based on how long your machine actually takes to stop at a given speed. It is quite literally the point of no return. And the best part? You can figure it out yourself. It's just 3 simple steps. First, inch your press down and just see at what angle does your tooling first touch. Write that down. Second, get the press up to production speed, hit the E-stop, and your SmartPAC will tell you exactly how many degrees of rotation it took to stop. Third, just subtract that stopping angle from your closure angle. That's it. So for example, let's say your die closes at 120 degrees, and let's say your press takes 30 degrees of rotation to come to a dead stop. You do the math. 120 minus 30 is 90. Your critical angle is 90 degrees.
That means any stop signal has to happen before the crank hits 90, or physics takes over and you are going to have a very bad day.
And this, my friends, leads us to the golden rule of die protection. You can write this down, you can stitch it on a pillow, whatever you gotta do. For any sensor checking something before the die closes, like a short feed or part position, your ready signal off angle must be set before that critical angle. No ifs, ands, or buts. That is the rule that makes this whole thing actually work. Okay, you've got the fundamentals locked in solid. Now, it's time for the masterclass. This is where we get into the advanced tactics. This is how we handle those really tricky jobs, and most importantly, how we get rid of those annoying nuisance stops for good. Look, a die protection system that's always crying wolf is a system that eventually gets turned off. That's just human nature. The real secret to a successful program is building trust with the operator. And we do that by using smarter tools like bypass windows and minimum actuation time to teach the SmartPAC what's a real problem and what's just a normal, harmless little flicker in the process. And that brings us to the most powerful weapon in the entire arsenal, the green flex sensor. Now, imagine this. This thing isn't just checking if something happened. It's verifying an entire sequence. It's smart enough to ask, okay, was the sensor on when my window started? Was it off when it ended? And hey, how many times did it flicker in between? This is next-level process control. And this quote just nails it. With the Green Flex, you are no longer just setting up a simple digital tripwire. You are programming an intelligent, automated inspector inside your die that verifies on every single stroke that your complex process is running exactly the way you designed it. So when you put all these pieces together, when you go from choosing the right sensor, to using fail-safe wiring, to calculating your critical angle, all the way to using advanced logic, you've gone on a real journey. You've taken that SmartPAC from being a simple crash cop, and you've turned it into the data-collecting, intelligent heart of your entire manufacturing process. And that really leaves us with one final question to chew on. After everything we've covered today, I want you to look out on the shop floor. Do you still just see a machine that makes parts? Or do you now see what it really can be? A powerful, intelligent manufacturing data hub, just waiting for a master like you to unlock its true potential. The choice is yours.